I think it can work. Okay, so I'm giving them permission to do the class asynchronously, which means y'all get recorded. The view that I'll be sharing is called, oh shoot, I just left the meeting. Ugh. The view that I'll be sharing with you all is, if you will, shared screen plus speaker mode. And if you know that, then hopefully you'll be able to then say, I'm good to have my image shared, but it's going to be behind Canvas, the link, and you don't have to worry about others who are not in this class seeing it. But like I did with last term, um, I recorded the bulk of the video sessions and would like to make that available to you all, future students. In spring term, I'm going to be doing a 513 as well. I want to make your video of this term available to them. And so if you don't want to be identified for some reason, you could just change your screen name. You could also be a total blank, sort of like not show your face, or even have a screen name that's totally obscured. Most students aren't that paranoid, but if you have a good reason to be paranoid, I'm not going to tell you it's wrong. I'm just going to tell you that this is what I'm choosing to do. And by being here and having your camera on, there is that risk that someone will see you next term or later this term in this class. Okay. So pretty much every day, I'm going to be sort of turning on the video for the first half of class. And then we'll talk about the nature of how things are organized, and you'll see why it's only the first half of class where the video will be on. So let's just maybe go from the top. Want to mention over here off to the left, I happen to have my portal opened. If you don't yet have familiarity with downloading and installing software, okay, you could chat with me in office hours about doing so. Yeah, literally under technical service request, I'm going to suggest that you request the software JMP. So under off to the left, technical service request, you fill in JMP in the little search bubble, and it'll say, okay, do you want it? You click yes, I do. It will download that software to your machine. The regular install process for this quarter should go smoothly, but every single quarter, there's at least one student who comes and says, I don't know how to do it. Meet me in office hours, share your screen with me. I'll step you through the process of getting installed on your computer if you can't easily do that yourself. So again, the software title is a JMP. That's a J, followed by an M, followed by a P, 3 letters. And it actually stands for John's Mac Package. And no, I'm not going to comment on that name. I will just say that it's the guy who worked at SAS in North Carolina in the 1990s got tired of running his statistical software analyses on a mainframe, so he built a front end for working with a Mac, and it's since then it's gone into it's a very popular software package. It's not the only one that I recommend. Minitab, some of you may have been asked to use Minitab for your former course. Maybe 312 would be a real common one, or 542, where Minitab might have been used. I'm going to, even if you used Minitab in the past, I'm going to encourage you to try JMP this term. Most students, most terms, even if they have experience with Minitab only before this class, they find that the lab activities that I write up for you, I've got instructions for both JMP and Minitab in most cases, and most students find they prefer the JMP software package because it's a little bit more accessible to people who are under the age of, say, 45, which is most of you. Okay, it's only older people who would probably tend to prefer Minitab, and that's because they're not used to newer software. So I'm going to say go with the newer stuff. Both packages could do entirely what you want. Other packages of note would include R. another package which will allow you to do absolutely every analysis we're doing this term. I will not help you beyond what's included in the labs with Minitab. I will be happy to help you with JMP, and I'd be happy to help you with R, but there will be no instructions provided in R this term. So I'm steering you towards Minitab, but if you want to do it some other way, as long as you have an additional resource or chat with me in office hours, we can help you out. Okay, so first things first, going from the top, there's a form I put online. About half of you, 2/3 of you have already done that, but the form is in Google, and I'm saying, okay, for the course, I'm going to have you at some point in time work in lab groups where you're going to be sort of working with a group of 3 or 4 others, okay, to sort of go through and talk about some problems. And those lab groups usually end up being study groups before an exam, and you're welcome to work with anyone on the homework assignment, but the lab groups are sort of a good place to start, especially if you don't know others in the class. By the way, none of you have interrupted me yet, or if you have, I haven't noticed. There's that blue hand thing that you could wave in the participants window, or you could put something in the chat, or you could just unmute and shout at me if you'd like. But if you got questions as we go, that's fine. But yeah, put in your Cal Poly email address, a name, stuff like, oh yeah, I'm just going to do the class the way I had intended to originally when I signed up for it. Nah, I already talked to you. I'm definitely having to do asynchronous. Well, as often as possible, I'm going to try to do asynchronous, but every so often I might show up in class. Okay. Yeah, group text, good idea. I will forward you towards Max McCool for a group text. Now, if Max, you put your phone number there, they can also send you a text as a way of sort of getting on that text list. So if you were going to be working with people in the class that you look around the room, you say, oh, I know that name and I like that person, or I know that person and I know they're smart. You'd say, I want to be in a group with those folks. Okay, tell me a list of up to 4 people here that you'd like to work with. I will do my best to sort of match you all up according to your preferences. And if you just say, I don't know, just put me in a group, I will. And it'll be based on whether you are definitely having to be asynchronous. The asynchronous people will all work together. The people who would prefer asynchronous, but sometimes may show up in class, they will probably be working together as well in lab groups, but they're allowed to join in breakout rooms during the lab portion of our class. And if for whatever reason you want to sort of fill out the survey twice, go ahead. Okay. And then Max, if later on you want me to save this file of the chat, remind me before the end of class, and I could do that, and we could cross-reference this and make sure we get everyone's phone number correctly. Max, hello. Are you nodding? I don't.
Yeah,
Which point?
that would be
Oh,
fantastic. Thank you.
yeah. Okay, so you got to remind me though, because
Okay, yeah,
otherwise, I
I
got
got
a lecture. I got a lecture buzz going, and I'll forget.
yeah, no worries. I got you.
Okay.
Thank you.
So, so fill out the form. Yay. You all successfully joined the class. And if somehow there's a classmate of yours who you expected to be here and they're sending you a frantic text saying, how do I get in the upper left corner, you should be able to see or click on a little thing that says, okay, copy the actual sort of a Zoom direct link including the password. You can copy and paste that into a text and send it to them or via email. What I tend to do is I tend to sort of, when I'm in a meeting, if I know it's going to be happening again, I do a quick right click and save that thing and then just put it in my calendar. So all I have to do is go to my calendar and click and I'm in the class. So that's a thing that I like. Oh, data. Every single data set this entire term that I know I will be using, with a possible exception of exam questions, should be found in this zipped directory. So I'm just going to go ahead and try and download that. I normally don't use Safari, so I don't know what's happening, but I'm assuming something's downloading. That's fine. Um, but once you've downloaded it, you'll see there's 3 separate directories, okay, or folders, if you will, inside of that downloaded archive. One of them is data from our textbook. It's called Graffenhales JMP. Okay, that's stuff related to our blue textbook. There's other homework problems JMP. That's sort of, well, other data sets that will be used for homework problems that are not specifically from our textbook. And then there's a third folder called class examples. So things that I have used in past 513 classes, or I intend to be using this term. And so if you want to follow along, you're good to go. I will also, during the course of labs, I will, in each of the lab assignments where I sort of put it online, I'll give you the ability to download the lab activity in both PDF and Word document form. And I will also provide a direct link to the data sets attached to the lab activity. Okay. Office hours. Okay. I didn't see you yesterday or today, but there's still a chance to click later today if you want to show up at office hours, or no, I'm sorry, tomorrow, or even on Friday. If for whatever reason you want to meet with me individually, the office hours are not currently overpopulated. But I will say that if you do want to talk about something and you're not able to sort of show up at any of those time slots, definitely send me a request. We'll figure out another time and place to meet via the computer. I will say this. It's easy if you show up at office hours for me to sort of excuse everyone else out of the room and quote, shut the door. Yeah, I can literally put you and me in a breakout room if you want to talk about something sort of personal or medical related to the class. That's always a very important thing for me to know. If there's something that you would not want to mention in front of the other people, but I need to know, definitely make me aware of that in some fashion. Email is semi-secure. So are Zoom breakout rooms. So let me know what I need to know to help you. Blah, blah, blah. Okay, class videos will be made available. I'm recording this now. I'm going to put it online later. It'll be sort of where I click weekly content. You're going to see, oh, look, there's a video. I'm going to put this right there. Review of the confidence interval and testing of two means. That's what I'm going to be putting that first week. It's going to be a video right here. This very lecture will appear as soon as I have it downloaded. Back. Come on. Okay, so there we go. Also, past terms worth of data. Fall 2020 is probably the most complete. I slammed that all onto YouTube and in a playlist form. And so if you go to YouTube, you can see pretty much all of fall 2020, starting in week 2 through the end of the term. I don't know. Do any of you know some of these other people? I mean, that's me. There's any of you BMed? Yeah, you know Omid? Okay, so yeah, that's him. So you'll see a couple people that you do recognize every so often, and you have the opportunity to sort of know which day it corresponds to. The day of our class will approximately correspond to the day in that class. Okay, if I have a chance to later this term, I will, instead of the clever names like week 2, day 1, I may even start to list in the description here on YouTube what exact topics and chapters it would cover. I haven't done that yet, but that would be perhaps very helpful for y'all. I'll get to that when I can. Okay, so there's that. I also like to do screenshots if I'm going to be writing out notes by hand or writing on PowerPoint slides or even highlighting something like, if I wanted to highlight something here, like this. I might very well take a screenshot of exactly that and then save that if that would be helpful for you all. I do highly encourage you all to take notes as we go, even though there is a video you could rewatch. Sure as hell, it's going to take a lot less time to look in your notes and find the relevant content than it will to sort of watch a whole video all over again. Okay. So there will be a place to watch another version of the same thing. You'll get to rewatch your videos. Yay. Stuff to do. Um, each week, essentially think the Tuesday, we'll do a class in Tuesday. Um, we'll do the lab on Tuesday. By Thursday at noon, when the next class starts, you'll have turned in the lab. Then Thursday, there will be a bit of a lecture, followed by a lab that you'll have to turn in by Tuesday of the next week. Somewhere along the lines, you'll turn in homework. Homework problems are due Monday at 11:59 p.m. No, let's make it a.m. Yeah, a.m. That's right before a.m. So that way the grader has a chance to sort of start on it before too late. So 11:59 a.m. Basically, if we do it in 1 week, like the first week, you'll turn it in by noon of week 2. If we do it during the second week, assign the problem anytime during week 2, you'll turn it in by noon of week 3, all the way through the whole term. Homework solutions will be posted. Yay. Don't turn in your homework late. I'm allowing the grader to take off points, as many as she wants to. If you do turn in late, she could give you a 0 for all I care. Okay, I let that be up to her. Don't piss off the grader. It's not a good idea. Okay, but I will say that if you do turn it in past the due date, a maximum score of 80%. If you turn in your homework after the problems, the solutions are made available to you, maximum possible score is 60%. So just be sure to be on track with that. The reason I want it to be Monday at 11:59 a.m. is that way I can put the homework answers online shortly following that to get you ready for midterm exams. And we'll see in the syllabus, the timing of the midterm exams may correspond quite nicely to a Monday 11:59 revealing of the homework solutions. Okay, so that's like a whole page of stuff. Do you want me to talk about any of that or move on and talk about the syllabus? Okay, syllabus time. Okay, so in the syllabus, which you may have already read, some of you are the sort to read ahead, others don't. I don't care. Couple highlights maybe is what I'm going to focus on, simply because if you don't have questions, that's fine. It's a lot of the same information, really. On the Canvas, the syllabus is as correct as it currently is. If I discover errors in the syllabus, in most terms, there's at least one typo that someone will ask about partway through, I'll make a change, okay, and then upload the current version of the syllabus to the Canvas. I will not be changing things like the way you earn an A or a B or a C or the percent of points for any particular grade. Or any particular course component. Certain things won't change, but if I have something like it says Thursday but it should say Friday, I'll make those changes in the syllabus and upload the current version. One thing though about the course Canvas is usually up at the very top, I will have ephemeral announcements like fill this out by Wednesday at 10. By Wednesday at 11 a.m., it's not going to matter anymore. So I'll probably go ahead and delete that link and I'll put in current information that you would really want to pay attention to. Like on Thursday, I'll have a direct link right up top saying Thursday's lab. It'll click you right into the Thursday lab where you could then get the content you need for Thursday's second half of class. So sort of key things that are going to be permanent, okay? And then up at the top, it's things that you want to see your attention having been drawn to them. You'll click at it right away, you'll look at it, and they'll probably disappear down the road. Okay, read stuff um, online. I'm just saying it's a pain in the ass. You know that. We're doing it. Um, JMP is the way to go. There are 3 texts for the course. I will call them the Blue Book by Graffin and Hales. That's the required text. Okay. Do any of you not have a copy of the book already? Okay. Buy one. And I'm gonna say it's inexpensive. It's on Amazon. It's like $50 or less. If you get a used copy, you could probably get one across a couple different textbook providers, shipped to you very quickly. The shipping itself, don't pay for the extra cost to have it shipped quickly, but buy it from someone who can ship it quickly. I am not making money. Actually, I do own stock in Amazon. Hold on. I still don't make money if you buy it from Amazon, but I just mention them because everyone has heard of them. If you know of a company that they say they'll ship you the book, but it takes weeks, don't buy it from them. Okay, get the quick shipping, and let me know if via email if you don't have a copy of the book yet. I can email you the material up through chapters 2. Okay, so anything up through chapter 2, I feel pretty comfortable making available to you because that will allow you to work on it. Okay, to work on the course material before your physical book arrives. And at some point in time, you're going to then have that physical copy of the text, and I don't have to worry about it. But okay, so if you could get it within about a week, or better yet, 10 days, that's ideal. Okay. If you order from someone who says it'll be a week before we ship and then it'll take you another 3 weeks to get it, that's not a good plan. Okay. 2 other books that I highly recommend. I used to call this the brown book, and I also have called it the green book because the previous editions are brown and green. Now it's the grayish book. Uh, Ramsey and Schaefer, they're Oregon State, whereas Graffin and Hales are from the UK somewhere. These 2 guys, biologists, or actually Rosie Hales, I guess she's a guy in the colloquial sense. These 2 guys are British or from the UK. These 2 are from Oregon State. A great book. If you're planning on continuing in grad school beyond the master's or taking another stat class after 513, I'd recommend getting a copy of Sleuth or Ott and Longnecker. Okay, Ott and Longnecker, okay, is so McCool said he sent something out to you. If you didn't get it, let him know. So Ott and Longnecker is more oriented towards people with an engineering background. It's not better or worse than Sleuth, but the books are written quite differently. Okay, so if you're of the engineering background, I'm going to recommend on Ott and Longnecker, or if you prefer an alternate text, there are other alternate texts as well I could suggest. But certainly, additional classes later down the line, get an additional book this term, and you can cross-reference it with our book, which has a fun and somewhat unique writing style. What's different about our textbook compared to most terms intro textbooks is it's very chatty, and it doesn't do a lot of mathematics, but it argues geometrically and via analogy. Okay, so let's rephrase that. The authors present statistical concepts in a way that even people who are afeared of math can grab onto the underlying concept, and they do it so well that even people who aren't afraid of mathematics tend to understand the concepts more thoroughly when using our textbook than if they were to use something like Ott and Longnecker. Okay. Sleuth, good book, just like, okay, Graffin and Hales, but it's a little bit more mathematical and in quite a bit more depth. It's also more expensive. Okay, so any questions so far? Okay, so now the thing that causes the most confusion, even with grad students across the whole of the term. How do I get a grade? Well, you do the coursework, or if you don't, you get a lower grade. um, with online, people sometimes have a tendency to put things on hold until later and then later and later. And it becomes easier when not really working closely with people to let things build up in a very bad way. So to try and counterbalance that, I'm building into the course something that will encourage you, we hope, to take the class very seriously and put in a lot of time early on. The reason is grad students quite often have to spend a lot of time at the end of the quarter on their other classes. I want to give you the option of taking the final exam via what I'll call option 2, the non-comprehensive version of the grading scheme. The final exam will have just the most recent material. So think 3 midterms. Midterm 1, midterm 2, and then the final exam, it's the length of a midterm. You'll have a little bit more time per question to do it, but essentially, if you score quite well on the first exam and the second exam, you can lock in some 44% of your grade real quickly on those 2 exams with a fairly high score. Most people do quite well on participation as well. Okay. Homework, labs, well, labs, most people score about 100% on them because I'm simply asking you to go through and do certain, I wouldn't say work that clarifies and develops your understanding. Okay. And if you simply follow through, you should be getting full credit on that. Homework scores, they tend to be pretty good because you're grad students. You work at stuff until you get the understanding. So it's the testing where students tend to struggle the most on 50-minute timed exams, and that's really what it is for this class for midterm 1 and 2. On 50-minute timed exams, if you find yourself rushed, you might score a little bit lower. But if you know the material very well, you will not be rushed. And you will do quite well on the test. And then that takes a huge burden off when you head after that second midterm, the last couple weeks of class, and then finals, because all you got to do is learn the new stuff, and that's it. If, however, you do feel rushed on the first 2 midterms, or perhaps if you don't know the material as well as you think you ultimately can, maybe you'll go with grading option 1, where each of the 2 midterms is half the weight of the final exam. So if you score a little bit below where you want to be on the first 2 midterms, maybe option 1 is what you want to prefer for the final exam. You have the opportunity to do a comprehensive final exam, essentially giving yourself the chance to earn some points in an area where maybe you hadn't earned as many as you had wanted to earlier. Okay, so any questions about the grading scheme?
When do you choose which option to go with?
Yeah, great question. Eventually is the answer. Uh, okay, so less evasive. Usually in the last week of class, I ask students during the last week of class, oh yeah, remember the options? And I'll tell you where you stand grade wise. I'll send you an Excel spreadsheet saying, okay, you've got a grade on Canvas that you could look at so far, plug in the numbers here. Here's the grade I would give you if I had to give you a grade today. Okay. And here's what score you'll need according to option 1 to get an A or an A minus. Okay. Or here's the grade that you need in option B to avoid getting a C. It'll be a lot of information in there. You'll just plug in your grades and it'll give you some clarity about which is the best option to go with. And I'll be asking you in that last week to commit. Okay. And by commit, I mean, just tell me what you intend to do. Okay. And if you change your mind, if you say, well, I prefer option 2, if you change your mind and say, well, no, I want to do the comprehensive test instead, you could do that as late as, well, shoot, when the finals due. Make sure that you get it done before the final. I mean, both options, both parts of the final exam will be available to everyone. And if you start in on the part E for everyone, that's what everyone will be taking. If you do the comprehensive addition to the final exam, well, I'll assume you want that also. But I will be asking you for information in week 10, just so that way I know about how many students I'll expect to be taking each version. That helps me plan my time for grading. The more students that take the comprehensive exam, the more time I have to spend grading it. And no, I don't resent grading. I just don't like it. Okay. Moving on. Here's about what we'll do and when. You can see today, nothing much at all. And then I'll remind you of some stuff that, yes, you should know pretty well already. Or shoot, if you took it 4 years ago and you took it at a junior college and you don't really remember anything, I'll today later define some terms. I'll show you some things that you'll say, oh yeah, I remember having learned that once. I'm essentially trying to set you up in the second half of class today, so that way you could then be successful on Thursday when we meet in class again. I'll talk about comparing two separate sample means to each other in the context of what we'll term a t-test or a t-based confidence interval. And then I'll turn you loose on the lab where you'll just do it. We say, oh, learn by doing, because I got the Cal Poly gear. I got to say, learn by doing. It's an obligation once per quarter. I have to say that. So I'll have you do it. Some classic data sets, and you will just tell me what your conclusion is. But the benefit is you'll be practicing using the tool of JMP, the software. And in case you're wondering, can I use JMP in the test? The answer is, I don't care. I write a test so that way, if you want to use the software, I'll provide you the data I use to generate the test. You could use the software if you want, but I write a test such that if you never open the data set at all, you still could answer every question completely from the information provided. So it's based on, do you prefer to use the tool or are you more of a pencil and paper person? Both would work just fine for the exams. So during the lab activities, you'll get a sense for whether you like JMP, whether you like your group mates or not, how well you sort of want to study with them. And then it'll be a good experience. And then you'll turn that in by Tuesday of next week. Tuesday of next week, we're going to start in on this thing called analysis of variance. And then you'll do a lab, and then you'll turn that in before Thursday class, where we'll continue down the ANOVA path, more work with analysis of variance. And then I'll have you do another lab, which you'll turn in by Tuesday of week 3. Repeat the pattern all the way through. Yeah, please.
You say they're due on Tuesday of next week. How will we be turning those in?
Okay, great question. The lab activities, I have not put the lab online yet, the first lab that corresponds to Thursday's class, but the lab activity, it'll be an assignment inside Canvas. And let's talk about the labs in general now. when you click into that lab activity, it'll say, here is a Word version, a Word document version of the lab. And you'll probably download that. And then here's a PDF version. You might prefer to download the PDF than the Word. I usually do Word, okay? Because when I work with others online, whether I'm going to be using Office 365 or whether I'm going to use Google Docs, I'm just going to open up the file with the others in my group. And then as you go your way through the questions, talking with each other, you'll do the analyses that are suggested or described in the lab activity. You'll each do them, and someone will cut and paste a section of the output right into the document, and then you'll talk about the way you want to wrap words around that output. Like, for example, and I'm going to sort of use terms that some of you will be familiar with, but others might not be yet. If I asked you to do a 2-sample t-test to compare the typical body mass between males and females, body mass index, BMI, if I give you data on the BMI of a collection of 32 males and 57 females, you could do the T procedure to generate that confidence interval. And then as a group, you'll talk about, how do I even phrase my results? You'll argue with each other. You'll agree upon ultimately a way of putting words to interpret that confidence interval into your lab activity. You'll eventually, one of you will save it as a PDF, please. And then you'll see in the lab assignment, okay, you'll be uploading the lab, one of you, for your entire group. All 4 names or all 3 names will be attached to the lab, and one of you will submit. I don't care who it is who submits it, but one of you will do that. And if for whatever reason you want to resubmit it later because you made a change, that's okay too, as long as it's before the due date. So Anise, does that answer your question?
That does answer my question. And last question, what time are those usually due? I know you said it, but I didn't get a chance to write it down.
Just think right before the next class session starts.
Okay, sounds good. Thank you.
If on Thursday we do it, you turn it in by Tuesday next. Most students turn it in, or most groups, I should say, turn it in by either later that day or the next day.
Okay.
But the due date is down the road a little bit. The Tuesday to Thursday turnaround, no one said that they felt rushed last term by that. And for students who are going to be doing this asynchronously instead of synchronously, and I'm sorry, where it says async t-test confidence interval, that is a typo. Crap, I thought I had eliminated that. Damn it. Okay, so I'm going to change that. The asynchronous thing is week 3 on Thursday, not week 1 on Thursday. I'll mention that in a little bit. We're going to actually be meeting and chatting live on Thursday of this week. Okay, but for asynchronous students, if you all, and I'm speaking to those of you on listening in now later or watching via videotape, those of you in that category, if you know that you aren't going to be working on Tuesdays and Thursdays, but rather say Wednesdays and Fridays, I can adjust the due date for you for the lab activities appropriate to when you guys are going to be working. And so maybe I'll be doing that for some of the groups if I know they are going to be doing the work asynchronously. If you can do it the same day as everyone else is, that's good. Okay, but if you can't, and let me know that it's going to be delayed by, say, a day or delayed by, say, 2 days relative to everyone else, as long as we have a regular time frame that your group could be turning in your material, that's really what I would want. Okay, so if you're following along on the syllabus, you could say, oh, like chapter 1, week 2, chapter 2 is week 3, chapter 3 is the first class session in week 4, and then all of a sudden we have chapter 4. Okay, but hold on, there's exam 1 as well. Exam 1 covers chapters 1 through 3. I'm going to release it to you all to take about 2 or 3 days in advance of it being due. So when is January 28th? That's a Thursday. Okay. So Thursday, January 28th by noon is when you'll have to have exam 1 finished. Okay. So I'll probably then put it out there on Monday or Tuesday. Okay. So just schedule yourself a little additional time for this class, some point in time before Thursday noon to do a 1-hour exam. Similarly, exam 2 is going to be on February 23. That's a Tuesday. Okay, so it'll be due by Tuesday, but the material will only cover up through what we had talked about the previous Thursday in class. So I'll probably release the test to y'all to take as of say Saturday. You can take it anytime Saturday noon till Tuesday noon. Okay, but that's actually this exam 2 is the reason why I want the homework to be due on Mondays. So that way I can get you the answer to the chapter 7 homework questions in time for you to be able to then read through those answers before you then have to take exam 2. Because if the homework questions are due on Monday at noon and the test is due by Tuesday at noon, giving you 24 hours of time to look over those homework answers seems the minimum I think is appropriate. In that same sense, that chapters 1 through 3, the homework won't be due until 24 hours. The homework on chapter 3 won't be due until actually afterwards, after you take the test. Okay. But for those of you who, oh, Max, you got a question?
Yeah. So I'm assuming since it's online testing and stuff, that's going to be open book for the midterms, right?
Oh yeah, great question. I don't care what you use.
Okay.
Other than don't use a human.
Right.
Don't have a statistician on speed dial. There's a good story about that on Reddit. Was it physics or engineering? I forgot which it was, but it was a great story. I think it was physics, but it could have been engineering because in many areas they're about the same. This guy realized his students were cheating one term. And so later in that term, he created an account via Course Hero and pretended to be a student saying, "Hey, I'm in the middle of a test. Can you help me with this question?" And then he had his grad students put in answers to literally an impossible question.
I saw that
Yeah.
story. Yeah.
That is classic. So look it up. Those of you who haven't heard the story, I'll quickly summarize it. He posted a question which was literally impossible to answer on Reddit or Course Hero. He had answers put in there that were completely bogus, and anyone who knew anything about the material should know the answer was completely bogus. And yet half of his students excused themselves during the test, walked down the hall with their phone, used Course Hero, looked it up, and got an F on the exam simply because they cheated, because no one would have answered the question that way other than had they seen it. I would not do that to you. Actually, hold on. Let me look. Okay, I wouldn't do that to any of you. But I would, however, expect that it's tempting to students. I've had students working away in a computer classroom where they quickly try and cover up what they're doing. And then I check the log of what's going on. They were using Wikipedia. Wikipedia is the worst thing for trying to answer a test question. Literally, I can't keep you from doing all sorts of inappropriate things, but I like to write test questions that discourage that there's very little benefit to attempting to cheat. one of the students that I met up with in Office of Students' Rights and Responsibilities after a cheating incident was suspected. He admitted to it and said, and it wasn't even a very good cheating experience because I didn't get any points for it. It was a lot of wasted time. So I'll write test questions that ask you to not just do basics, but rather to think through the problems. So does that answer your question, Max?
Yeah, that's perfect. Thank you.
I do highly recommend, and this is sort of down towards the bottom, an 8.5 by 11 piece of paper, one-sided, where if you were to be doing an in-class test and you were trying to cheat and limit yourself to one page, because notes are easy to see, or if you were allowed a one-page 8.5 by 11 note sheet, what would you put on that? That's what I'd recommend you do. And that could be as simple as, like 4 columns and 5 rows. The rows could correspond to the different chapters on the exam or the topics on the exam. The columns could correspond to the name of the topic, maybe an equation, a worked out example, words that describe and explain the concept. Yeah. And then maybe the last column for this term could correspond to references that you'd want in the book, like see page 53 in the text. So you have a quick place to turn. So that way you don't spend your time flipping through the book. Have yourself a good, if you will, table of contents for the stuff you're going to need for just the exam. That's a really helpful thing to do. Okay. So that's, I think, my schedule for stuff. And in past terms with 513, what I like to do is approximately follow this schedule. But if students ask questions and it takes us a little bit longer to get through one topic and we get through another one a little bit more quickly, I'm fine with that. We're always able to get through the bulk of the material the right way and at the right time, it seems like. Even though we might be a class session behind where the syllabus suggests we ought to be at some points in time in the term, I won't mind. That's okay. So don't hesitate to ask questions on the topic any point in time during the term. Okay, so that's a lot of me talking for a little bit. Some of you are like smiling, literally smiling. Others of you are smiling inside because I can tell. Do any of you have questions about anything that I've mentioned thus far, or things that you were wondering about after reading the syllabus? Oh, then is to sort of show you one maybe worked out example of a confidence interval for one population mean. And in the process of doing that, we'll talk about things like the central limit theorem. We'll talk about what you might very well call a standard error or a margin of error. Those are 4 separate things. Okay, so I'm going to see if I could grab the right example and class data examples. And I think catfish are fun, so let's talk about catfish. If you happen to have downloaded the file, the stat 513 data sets example, I'm using the catfish 3 data set here. Okay. And let me tell you a story about how these catfish were obtained. And then we'll go from there. Okay. In Virginia, where I lived for a period of 5 years, I was involved in a project with a grad student in biology there named Lowell Ballard. He worked at Virginia Commonwealth University as a grad student, working with 2 fisheries guys. One of them was named Greg Garman. And Greg Garman had an in with the Department of Environmental Quality, DEQ. And they believed that the reason there were so few American shad in the river systems of Virginia is because of imported non-native catfish species. Okay, so there's a biological backstory here. I'm not going to go into the political backstory behind the biological backstory, but the biological backstory is we're wondering about whether the non-native species of catfish that had been imported from the Missouri and Mississippi river system were tending to have more American shad in their stomachs than the native catfish species. You'd sort of think an apex predator is going to be eating everything in sight, and catfish in a large river would be one of the apex predators, okay, especially considering the length of some of these. This is the length of each of the fish in my data set in millimeters. So 542 is half a meter long. That's about that long. So that's pretty big as a fish goes. Okay. The fish lengths may be different by the different species of catfish. There's 4 species of catfish. There's blue catfish, BCF, channel catfish, CCF, white catfish, WCF, and flathead catfish, FCF. And so I'm sort of wondering a couple things. One of them is, are the species with the same distribution of lengths? And then secondarily, can you tell me about the lengths of the blue catfish on average? So I'm going to sort of dive in and show you a couple things that JMP will allow you to do that will be helpful for the lab this coming Thursday. You might notice up at the top here under JMP. Now I've got this Mac operating system. If you're using a Windows operating system, it's going to look a little bit different, but still you'll see always the options, things like file, edit, tables, rows, etc. Look for the one called Graph. And under Graph Builder, you can then do a drag and drop. Okay, this is JMP's beauty. It's easy to produce certain sorts of plots. And I think I'm curious what the lengths of the fish are like. Okay, so I dragged length over onto the x-axis. And here's a, if you will, a dot plot describing the lengths. And these lengths are sort of spread throughout a wide variety of Y ranges. We haven't assigned anything to take the role of Y here. I'm just saying it looks like a lot of the fish are less than 400 millimeters in length, but some of them are quite long, like 1.2 meters or so. If I take species here, highlight it, grab onto it, and drag it over to where it says species, drag it to the y-axis, it says, okay, on the y-axis, I'm going to list the 2 species available, okay, CCF, channel catfish, and BCF, blue catfish. I believe the FCF and white CF, white and flathead catfish, are not in this data set. Or if they are, they've been, oh, no, sorry. I apologize. I'm going to start over. You might have noticed, and I unfortunately saved a version that had this sort of a pattern to it. Notice that there's this little red slash thing. That's the sort of the sign for, yeah, no. It says, do not include this data set, exclude this data point from any analyses that you'd be doing. What I want to do is highlight one cell that looks like it's been excluded, and all the flathead catfish were excluded. If I select all the cells that match an FCF flathead catfish, I can turn off the hide and exclude feature. Where's exclude, hide, unhide? Yeah, good. So now notice that none of those FCFs are hidden If I find a WCF white catfish, I can then turn that off as well. Okay, there are some of them. I wish I had not saved this particular version of the data set. I apologize for that. Select matching cells for the white catfish, and I'm going to exclude or not exclude. I'm going to include them. Okay, so good. Now that I'm looking at my data, I want to take the lengths, look at the different lengths across all the catfish in the sample, and take the species here and put this along the y-axis. Here are the distributions of those 1, 2, 3, 4 separate species. The white catfish, flathead. Well, we don't see so many flathead catfish. We see a lot of blue catfish, a lot of channel and white, not so many flat. Blue catfish the most. Okay, you can see up at the top, different sorts of plots could be generated. If I wanted to look at a box plot, I could say, show me a box plot instead. If you're familiar with box and whiskers plot, you would remember, oh yeah, this is the first quartile, the median, the third quartile of lengths of the fish. There's the minimum and then the maximum, and those are deemed outliers because they're beyond the inner fence. Okay. What about here? We have, for the blue catfish, a lot of outliers, if you will. And the way the outlier is defined is, well, it's any data points that are more than 1.5 interquartile ranges. The difference between the two quartiles is the interquartile range. 1.5 times that above the third quartile. The largest data point that's inside that range forms your whisker length. The smallest data point less than the third quartile, but if it's not outside that inner fence, we would not deem it an outlier. Outliers are beyond that fence. Max?
Can you repeat the definition of an outlier real quick? Sorry, I haven't taken stats since my sophomore year.
Yeah, well, okay, so number one, the conceptual definition from the point of view of this class is a data point that lies outside the overall pattern
Right.
of the bulk of the data. So the bulk of the data fit a certain characteristic. Outliers are ones that don't. But yeah, literally for flathead catfish, if I say, here's the first quartile, there's the third quartile, Q3 and Q1. The difference between the quartiles is called the inner quartile range, IQR. And that IQR is a measure of spread, literally how widely apart are the first and third quartiles. And if I take that IQR and go up 1.5 times it, I get this fence, if you will. If you're inside the fence, you're a non-outlier. If you're outside the fence, you're shown as an individual dot.
Right. Okay, cool.
Yeah. So it's just a 1960s ad hoc definition by a guy named John Tukey who worked at Princeton at the time. Do any of you do signal processing? Fast Fourier transform or anything like that?
I've done it before.
Okay, so John Tukey is one of the guys that came up with the discrete Fourier transform. It's the Cooley-Tukey algorithm that is used for pretty much all signal processing these days. He was a statistician, but a mathematician also, and also an engineer of sorts. So he just came up with a way of describing what he deemed an outlier. And we've said, good is enough for us. We'll run with it for this graph. Okay. So let's look at just one species of fish. And I want to go with just the channel catfish, the CCF for now. If I were to take the channel catfish, let's find one of them, a CCF, boom, highlight it. If I right click and say, I want to select all the cells that are channel catfish, and then I'm going to right click and I'm going to invert my selection. Invert my selection. Now I've selected everything that's not a channel catfish. If I now right click and I can hide and exclude those non-channel catfish data points. Literally, I'm saying, don't include the red slash, don't include those data points in any analysis, okay? And B, hide it in any plot. Little mask thing is for hiding, don't show it in a plot, and don't include it in any calculations. So now I've got just the channel catfish. If I were to analyze now the distribution, analyze distribution is your friend. Analyze the distribution of the lengths. I'm going to be looking at the lengths of just the channel catfish. And for whatever reason, when I do my analysis, I end up with the output appearing in a different window. So I like drag it over so I can show you. It looks as though this is stacked up funny. Literally, I want to stack it up regular, not funny. I like my x-axis to correspond to my data. So I'm going to put it along the x-axis rather than our earlier version along the y-axis. Basically, you think we took it and it was rotated vertically. We made it horizontal, rotate it some 90 degrees counterclockwise. Okay, it's the same graph. Actually, hold on a second. I got that one wrong. The high numbers are up here. So if so I'm going to rotate it 90 degrees clockwise and then take those bars and swing over the axis. Okay, there we go. So we have our histogram of the values. The smallest channel catfish is quite small. The biggest one is over 0.5 meters in length. Here is my box plot or my box and whiskers plot. You can see things like the average 321.3 millimeters, the standard deviation 99.4 millimeters, this thing called the standard error of the mean. We want to talk about that, and then an upper confidence interval, 95% confidence interval for that mean. So what I want to do is to switch gears a little bit and show you a blank background that I can write on. And darn it. Okay, I'm going to drag these things off. So I'm only left with the things I want to show you. Okay, so here's what I want to show you, and I'm going to work in the white space available here. And you are able to see the screen okay?
Yep.
Okay, so this is goofy. Okay, so I've got the ability to, with my iPad now, write on your screen or my screen directly. So I'm going to go with black at first as colors go, and then I'm going to maybe switch into other colors also. Okay, so what we have here is an average. Okay, I'm going to term that X bar, the average, is 99.43. I've got a standard deviation. I'll term that S. I'm sorry. That's the standard deviation is 99.43. So let's go ahead and redo this. S is 99.43, and then X bar is the 321.3. So I've got the mean and the standard deviation, the sample size, the number of individual fish of the channel catfish variety is 801. Okay, so those are numbers which I guess if you look carefully, you can spot them right in the output. Okay, so let's work with that data. And let's think conceptually, did we get all the channel catfish, the entirety of the James River in our sample? No, we didn't. We only got the 801 channel catfish that Lowell and his buddies at the Department of Environmental Quality caught one summer. Yeah, literally, he went out one summer and said, I'm going to get in a boat, motorboat, and go out, and they fished all day long. And every fish they caught, they identified the fish by species. And then after identifying the fish by the species, they measured its length and the weight of the fish. And then he tossed it in a bucket of ice and went back home to the lab at night and took the fish and gutted it and opened up the stomach contents and counted the number of items in every stomach and even identified every single stomach item. Yeah, literally, was it a wasp? Was it a cigarette butt? Was it a smaller fish? And if so, was it an American shadfish, partially digested? He determined the stomach content entirely. Okay. But we have the desire here to analyze the lengths of these fish. And I believe there's a population of the fish lengths. And there is a histogram of the fish lengths. Now, I drew this in here, not necessarily normal in shape, but there is a mean of the population. And there's the standard deviation sigma of the population. Okay, S is the standard deviation of the sample. The sample data of 801 individuals is a sample from the entire population. I want to know the value of mu. Now, one of the things you'd think is if you sampled in a fair way, without bias, if you will, if you obtained fish in such a way that you are no more or less likely to get larger fish than smaller fish, your sample of fish should be representative of the population of fish in. Your sample should be representative of the population. Does that make sense? Okay. So I don't know mu, but we would like to believe a few things. I'm going to go ahead and move forward to another. I'm going to go ahead and clear this, and I may come back to this later. But I believe that the typical value of the sample mean is the mean of the population. Okay, so on average, the sample mean equals the population mean. So it's a subtle concept, but let's think this through for a moment. If you went out fishing in the James River one summer, 1993, and you caught, actually, hold on a second, was it 93? Yeah, it was 1993, and you caught, okay, 801 catfish, would your sample average be the exact same as Lowell Ballard's sample average? Probably close, but probably not exactly. Would a wide variety of people, thousands upon thousands of people, if they all went out and did this, and if after catching the fish and measuring the length, they threw it back, if we did this over and over and over again, would we have lots of different possible sample means? Certainly. So here's our way of saying, on average, over the different possible samples. On average, over every possible sample, the sample mean equals the mean of the population from which you're sampling. Secondarily, let's go ahead and clear this and get you another page. Secondarily, there's a standard deviation, okay? And I'm going to call that sigma x bar. It's the standard deviation of the distribution of the possible x bars. Again, a wide variety of possible sample means could occur. You could get a sample mean, Lowell Ballard could get a sample mean, I could get a sample mean. Thousands upon thousands of people, had they been the one to go fishing, they might have chosen simply a different slight time of day. They could have chosen a different method of baiting their hooks. They could have had a different sample of 801. But if I'm going to sample 801 times from that population, there's a lot of different possible sample means. The standard deviation measures the spread of those. And we know from the law of averages, that's equal to sigma over the square root of the sample size n. Let's rephrase that. If n, the sample size, were to grow larger, the distribution of the possible sample means grows smaller. Let me say that one more time. The larger your sample size is, the closer your sample estimate is likely to be to the mean of the population that you're sampling from. On the previous page, we said on average, the sample mean is where the population mean is. Here we're saying the distance away from the population mean that your sample mean is dependent on the sample size and also the standard deviation of the population. Okay, so that's the standard deviation of the distribution of the possible sample means, but that number relies on us, if we're trying to calculate it, relies on us knowing the actual value of sigma. Sigma, what is sigma? The standard deviation of the population that we don't even know the mean of. I mean, if you don't even know the mean length of channel catfish in the James River in 1993, how much less likely is it that you know the standard deviation of the distribution of lengths of channel catfish in the James River in the summer of 1993? You just don't. You're not going to know it. Sigma, the standard deviation of the population, is unknown. So what we do is we come up with what we will term SE, the standard error of X bar. And that's S, the sample standard deviation over the root of N. Okay. And that's the standard deviation or the standard error of the sample mean. Now, in our case here, the claim is that's 3.513. My suspicion is if you were to take that as S over the root of N, 99.43 over the root of 801, you can verify that that's true. Now, I don't always do this, but for now, I'm willing to pause for a moment. Could one of you pull out a calculator and just check to make sure that that's true? Because wouldn't it suck if the stat package were wrong?
I kind of have a side question real quick too.
Sure, go for it, Max.
So the fact that you were talking earlier about repeating it and everyone getting a different distribution from the new N, but the fact that he has substantial outliers, especially I forget for which species it was, but for one of them, when you look at like fish sizes and graphs over, I've done a lot of stuff on work with salmon, just in environmental science, but the fact that he killed a lot of the largest outliers when he was, dissecting them to research our stomach contents, wouldn't that skew future ends to make it?
Okay, yes. If you're using destructive testing, which in this case, to classify the items of the stomach properly, you have to remove them, which means the fish is dead. Yeah, you can't really have hundreds and hundreds and hundreds of people all doing the same thing during the same summer.
Is there a way to take that into account statistically, the fact that you're killing off some of the largest outliers that are most likely going to skew the results in the mean?
Well, I'll answer that question after I answer a more important question first.
Okay.
We don't actually sample more than 800 fish, 801 of this species. That's the total number that were sampled of the tens and tens of thousands of fish in the James River. I mean, he was sampling across about a 20-mile stretch. Do you know Richmond, Virginia area, Max?
Yeah, I've been there.
Okay, so basically think where the waterfalls are at the west end of Richmond, 20 miles downstream to about where the plantations start.
Yeah.
Shirley Plantation is about 20 miles away. So that's the stretch where he was working. Tens of thousands of channel catfish there. We don't worry about sampling 800 out of tens of thousands.
Right. Okay.
But now to answer your real question, it's not the outliers that are the problem. And removing the outliers, we don't really care about. It's
Right.
removing a substantial fraction of the population as your sample.
Right.
There is a finite population correction factor that we would need to incorporate if you sample a large number of times out of that larger population. So let me put in that finite population correction factor in the next line.
Okay.
Okay, that's it's equal to that, or equal to s over the root of n times then the root of, I always forget the numerator and denominator. Okay, so it's capital N minus 1. No, capital N minus lowercase n over capital N minus 1, where capital N is the population size. So if you literally have lowercase n, say 800 out of capital N 900, yeah?
Yeah.
What you could think is numerator wise, you have 100, and then the denominator, you still have about 900. 100 over 900 is 1/9.
Right.
The root of that is 1/3.
Right.
So your standard error is showing extra precision from having seen the majority of the population in your sample.
Okay.
So this matters if lowercase n is more than capital N over 10. If you're ever observing more than about 10% of the entire population as your sample size, you might want to include this finite population correction adjustment.
Okay.
And we got to talk about salmon like right after class ends, because I want to know what you do with salmon, because I have a history with salmon, not just eating, but studying.
Oh, for sure. Yeah. Yeah. I spent a lot of time growing up in Portland, so we used to go fishing all the time.
Yeah. Okay, so this standard error, okay, I claim should be 99.43 over root 801. What do y'all get when you did that? Anyone?
I got the same.
Woo! I am so remembering my equation. Yay. Okay, so, but Chase, thanks. I think the reason I wanted y'all to do that is if you bring a calculator with you, or you can reach down and grab it out of your backpack, or hell, if you're doing entirely online only, if you have it near your desk, sometimes it's a whole lot more convenient to have it handy rather than just rely on someone else. And the reason I encourage you to follow along and do the calculations as we go is that, boy, it would suck to not have practiced this and then you end up on a midterm and like you screw it up. Okay, so if you haven't yet checked that, I would go ahead and verify that you do get the 3.51. Okay, so let's change gears again. This is a standard error, and the standard error tells us the typical distance between our sample mean and the mean of the population that we're using the sample mean to estimate. So I'm going to sort of not completely clear this, but I'm going to erase some and I'm going to write down the definition of the standard error. I don't know, does the sound effect work? I don't know if the sound effect actually helps. Okay, so what is the standard error? The standard error literally is an estimate. Color pen, do a pen, good. Estimate of the distance between, or estimate of the typical distance between X bar and mu. X bar is your estimate of mu. You want to know mu. You're doing the study for a reason. You want to know the average length of a channel catfish in the James River in 1993. And so we're going to use the sample average, X bar, to estimate that unknown underlying mu. Because X bar on average equals mu. Yeah, your X bar might be too high or someone else's might be too low, but the method of using the sample average to estimate the unknown population mean, that is a solid method. And how far off are you going to be? About a standard error or so. Okay, switching gears one more time. The concept then that we have with a margin of error, okay, is the following. And I'm going to speak approximately the way you probably first heard a confidence interval and a margin of error described in your previous stat class. Then I'm going to fine tune it a little bit. X bar plus or minus 2 standard errors. That's your estimate, plus or minus a margin of error, MOE for margin of error, should contain mu about 95% of the time. Yeah, literally, you may be familiar with that other stat class where we said, oh, plus or minus 2 standard deviations happens about 95% of the time if you have an approximate bell-shaped curve. If you have a large enough sample from the population, and by large enough, we mean 30 or more. In this case, 800 is at least 30. We would say we have the distribution of the possible sample means X bar follows about a normal curve. That's called the central limit theorem. If I therefore go up and down about twice sigma over root n from the sample estimate of X bar, I should be capturing mu 95% of the time. Well, the same thing works with standard errors. The standard error is S over root n. So here is our method called the confidence interval. So let's go with let's go with a rectangle. Here is an approximate 95% confidence interval. For mu. Because although your sample may be too low on average, and Lowell's may be too high on average, 95% of individuals with a sample of 801, when using this procedure, get your sample of 801, take the sample mean, X bar, plus or minus 2 times S over root n, about 95% of you all would capture mu, the population mean, inside of that range of numbers. Okay, so let's fine tune this and make it perfect. That's an approximate 95% confidence interval. Let's make it exact. X bar plus or minus T, what I'll term as alpha over 2, with n minus 1 degrees of freedom times s over the root of n is an exact 95% confidence interval. For mu. Okay, so a couple things to note. One of them is S over root n. That's again called the standard error of the sample mean. Second thing is the number t sub alpha over 2 comma n minus 1 degrees of freedom, df, is n minus 1. And if you remember that past stat class, you had a t table. And in that t table, you could look up the n minus 1 degree of freedom row to get the appropriate t value for an upper tail area of alpha over 2, or if you will, a central area of 1 minus alpha central area. So if we have 95% confidence in the middle, 95% certainty in the middle, that's an error rate alpha of 0.05. That 0.05 or 5% is split evenly between the upper and lower tails. We've got t for 0.025 is the number we're telling you. 2.5% in the upper tail means also 2.5% in the lower tail, 95% in the middle. So what? We're 95% certain that this procedure will actually capture the mean mu. Okay, so for fun, I'm going to say I want to know 328.2 minus 321.3. Calculator people, help me out. 328.2 minus 321.3.
6.9.
6.9. 6.9. Okay, so the distance that you go up is 6.9. How about 321.3 minus 314.4?
Also 6.9.
There you go. So from the mean, which I'm going to highlight here in red, you go down 6.9 to get the lower, and you go up 6.9 to get to the upper value. So 6.9 sounds like that margin of error, right? Just for fun. What is twice 3.5? Sorry, dog.
7.
Ah, so it sounds like we went up and down about 2, just a hair less than 2 standard errors. Okay, so that seems to be, hold on a second. I've got a dog here and a kid here, and we're going to try and negotiate the volume. I'll be right back. Can you, Bridget, take the dog to another room? Yeah. Thank you. Okay, so that's, as far as I can tell, a way of describing and explaining the confidence interval. Literally, JMP, if you say summarize for me or analyze the distribution, it'll tell you things like the quartiles, the mean, the standard deviation, that standard error for the mean. That's about how far off your mean sample mean is likely to be from the truth. And if you want to go up and down a range of values to be 95% certain to capture the truth, you go down about twice that, but the software will do it for you auto-magically. Is that convenient or what? I'd rather do that with the software than by hand. Would that be hard to do by hand on a midterm? By the way, I'm not going to put this on a midterm, but would it be hard to do? Not
Well,
really.
How would you do the t-distribution part of it?
Ah, great question. Well, I will provide to you a t table. And I will also provide to you a way of using JMP to get a T value for for this procedure. I don't want to overload you today with too much, but I'm saying, didn't you take a previous stat class?
I took one on random processes specifically, so we didn't
Oh,
actually go
yeah.
over this.
Okay.
It's interesting though.
So no, it's you are the outlier in this sense. So yeah, I will talk in office hours if you want to know how to do it by hand, but in class later I will show you how to use the JMP online T distribution calculator. And if you want to do it with paper and can't figure that out by yourself, or you want to chat in office hours, that's easy to do. But the bulk of you are familiar with, okay, I got a table, I can look it up, I'm good to go. Okay, so that's it for me today in terms of what I wanted to be able to present to you. Very light, not some of you are thinking, oh my God, that's light, whatever. Not much content, more of a review than anything else. You're gonna note that class tomorrow and then all of next week and all of the week after that could nominally be called review as well. But certainly this first week should be review for most everyone completely. Whereas weeks 2 with analysis of variance and week 3 with regression, you'll all have seen a little bit about it, but not necessarily quite the depth coverage that we'll find you'll be remembering in class on Thursday. Okay, so that's it for me. I'm going to turn off the recording unless one of you has a really quick question that I want to be on the recording. Anyone question?
Can we use the data that we collected from our projects in this course?
Will you be using it?
Yeah.
Not for my class.
Okay.
I do think it's a good idea to mention what you're doing in office hours, Ted, or send me an email description of the problems that you're working on and how the data were collected, because I can then start to build in similar examples into our class discussions. You know, if I'm lecturing through something and I know, oh, 3 of the students are from Wine and Vit, for example, I'll start talking about things like verasion or dropping fruit. And, you know, if I know enough about your discipline that I can then utilize the things that you tell me you're interested in, often it makes it a lot easier for y'all to get the job done. Especially for people in some of the very applied areas, that can be very helpful. So don't hesitate to tell me what you're doing. Anyone else?
I had a question about the I think you called it the finite population
Correction factor. Yeah.
correction factor. Yeah, that so you introduced that purely because the sample that you were describing, you didn't replace the fish back, right?
Correct.
Okay, so that's why you would include that factor.
Yep. Now,
Okay.
if well, actually, if I didn't replace the fish between every consecutive capturing of a fish, if I'm going fishing and then I pull one out and then I measure the length and toss it back in and I could possibly get it again in my sample, I would not need to worry about that finite population correction factor. It's if I keep it out of the sample that I would need to do that.
Okay. Okay. And could you explain some intuition as to why it like reduces the overall, I guess, estimation of the standard deviation?
Okay, great question. I love it. Let me ask you a question. Suppose you have 30 friends exactly who live in San Luis, and you want to know the average height of your friends who live in San Luis, and you ask all 30. Don't you know exactly the average mu of the heights of your 30 friends in SLO?
Yes. Yes.
Okay, so there is no error.
Mm-hmm.
Now, if you have 300 friends in San Luis and you only ask 30 of them, well, you're only asking a sample from that greater population of 300. And so the sample is an estimate of the unknown population mean. You know exactly the population mean if you sample the entirety of the population. The larger the fraction of the population you see, the less imprecision there is, or the more precision you have, because you got the bulk of the population in your data set.
I see. So you're reducing the deviation, scaling it down as you have more samples because you're more sure about the number.
You see a larger fraction of the exact population as your sample. Exactly.
Is there a theoretical backing for that, or is it more like empirically driven?
Oh, no, that's theoretical.
Okay,
And
interesting.
it dates back to the late 1800s with a guy named Kolmogorov. Kolmogorov? He's a Russian.
Thank you.
Someone else? Okay, so I'm gonna sort of stop the recording and call it a day. I'm happy to hang out for a while and keep